Solving equations with rational coefficients, the fractions. So recall that when you have a half plus a half, this is called an expression. The reason being there is no equal sign. A half plus a half equals a half x. This is an equation, which means you could solve for the x by rearranging the equation. When trying to simplify an equation with fractions, what kind of numbers would you multiply? You're going to multiply by the lowest common multiple of the denominator. Why? It allows us to eliminate the denominator, hence no fraction. So this is one way you can solve for it. Summary. To eliminate fractions in an equation, multiply every single term on both sides of the equation. When eliminating more than one fraction, find the lowest common denominator and multiply all terms by this value. So let me show you a quick image. What is a lowest common denominator? So you need to have that understanding before going on. So as a quick example, if you have a half plus 1 over 6, I wrote that the LCD is 6. Do you know why? So the LCD is 6 because if you think about the multiples of the number 2 and 6, multiples mean multiples of 2 are 2, 4, 6, 8. If you kept multiplying that number by 1, 2, 3, 4, etc. The multiples of 6 are 6, 12, 24, etc. So what number did I say twice of between those two lists of numbers? Well, between the two numbers, I said 6 twice. An LCD is 6, and it is the first common multiple between the two, and therefore 6 is the LCD. So I'm going to do a couple of questions. First, 5 minus k equals 2 over 3. So question A. So according to the steps, it says multiply each term by the LCD. So you do need to think of this whole thing. Um, you can think of it two ways, and in this case, we're saying that you have a denominator of 1 and a denominator of 1. Well, the LCD between 1, 1, and 3 is 3. So you're going to multiply each term by 3. Okay, so sometimes you might see me use a multiplication sign, sometimes you might see me use a dot so that you don't get confused with an X. So in this case, I'm going to use the dot. So 5 times 3 is 15. 3 times k is 3k. I'm going to leave the negative there. 2 times 3 is 6. 6 divided by 3 is 2. Or you could say that the 3's would cancel out. Why? Well, if I move this over, these would cancel out. Because 3 divided by 3 is 1. 3 goes into itself once. So 2 times 3 divided by 3 is reduces eventually to a 2. Am I done? No. But you've seen these kind of equations before because we've worked with solving an equation, right? So once we've done the first step, you've seen it before and you're solving for the variable. How? You're doing BEDMAS backwards. So BEDMAS backwards meaning I am doing addition or subtraction first to get my k by itself. I see that the k is being multiplied by -3 and adding by 15. So what's the opposite of adding by 15? Subtracting by 15. So I get -3k is equal to -13. Dividing both by -3, I get k equals 13 over 3. That's question A. Question B. So the LCD is, well, between 5, 4, and 10, the LCD is 20. How do I know that? The list of numbers for 4 is 4, 8, 12, 16, and 20. These are all the multiples of 4. For 5, it's 5, 10, 15, and 20. For 10, it's 10 and 20. Well, what number did I keep seeing? 20. Okay, and so I'm going to multiply each term by 20 using the dot. Okay, so if I leave it like that, sometimes it won't be really clear for me what part cancels out how. So I'm going to write it like this. So 20 times x minus divided by 5. minus 20 times 2x divided by 4 equals, and I'm going to just move that over to the other side, and I have 20 times 1 over 10. Okay, so then I have, these parts cancel out, because if I have 20 times x divided by 5 goes into 24 times. And 5 goes into itself once. Or another way of saying it is 20 divided by 5 is equal to 4. 4 goes into 25 times. 4 goes into itself once. Or 20 divided by 4 is equal to 5. 20 goes, 10 goes into 20. You always think of the small number into the larger. 10 goes into 20 2 times. And 10 goes into itself once. So these kind of reducing these fractions will really help you reduce, and so that there's less mistakes later on. It might look complicated at first, but once you get used to it, it'll be easier. So 5 times 2 is 10x, and then equals 2 times 1 is 2. So see how clean that looks, and it's a lot easier to look at than the first line or the second line. You could have, mind you, done 20 times x divided by 5, and you would have eventually got the 4x. You could have done 20 times 2, which is 40x, and then 40x divided by 4 is 10. 20 times 20 times 1 is 20, divided by 10 is 2. So that's also totally fine. I'm showing you a way where you're ensured to reduce fractions from the very start. So you have negative 6x equals 2. You're going to divide both by negative 6. And now you have x equals negative 1 over 3. So I'll do one more example, or two. Okay, so this one over here, C. 1 over 4 bracket x minus 3 equals 5. So I am going to find the LCD. LCD, well, is it 20? No, it's not, because the 5 has a denominator of 1. I really am only looking at denominators. And between the two denominators, 4 and 1, the denominator is, the LCD is 4. So I'm going to multiply both by 4. And I would get, well, 4 times 1 divided by 4, or these parts cancel out, and I get a 1. Bracket x minus 3 equals 20. I can really get rid of that 1 because it's not really doing anything. And it's nice and simple now, a lot better than what it looked like before. I'm going to get x by itself by adding 3 to both sides, and x is equal to 23. Awesome. And mind you, there's also another way of solving some of these questions, and I won't explicitly write it down, but it's called cross multiplying. You could have solved some of these questions, like C, by cross multiplying and see if you can get the right answer of x equals 23. This works because we have a monomial equals a monomial. I can treat all of this as a monomial because it's all under a bracket, right? Moving on to what question do you prefer? So we're gonna do, let's say F. Let's do F, and let's say, okay, so a common mistake is that we need to put brackets anytime we see a binomial, because sometimes you can make a mistake when you're, if you don't do that because you don't do the distributive property. So put brackets. The LCD between 4 and 7 is 28. So you're going to multiply both sides by 28. And so you get, so I'm going to put that 28 at the front, times y minus 3 divided by 4 equals 20 bracket y minus 8 divided by 7. Well, 20 divided by 4 is 7. So that becomes a 7. 4 becomes a 1. 28 divided by 7 is 4. So, or 7 goes into 28 4 times, 7 goes into itself once. And so you have 7 bracket y minus 3 equals 4 bracket y minus 8. Therefore, you're going to do what? You're not done there. You're not going to be able to solve for y if it's in brackets like this, you gotta right now try to get just one y. I need the y's to be collected. That is the reason why I'm doing distributed property, and I have 7y minus 21 equals 4y minus 32. Now I'm going to try to collect like terms, and I'm going to try to put the variables to one side and numbers to the other. It doesn't really matter which way per se. I'm going to move it to the left because I see a bigger y value towards the left. That gets rid of the y's on the right. I have 3y minus 21 equals negative 32. I'm going to add 21 to both sides to get rid of those. I have 3y equals negative 11, and I'm going to need to divide both sides by 3. That way I have y is equal to negative 11 over 3. Okay, you can check the other answers with the full solution I will provide to you.